Okay, so our introduction to equations. In our last topic, we looked at expressions, and we're going to be going on from that. This is building on that topic. An expression is a collection of pronumerals, numbers, and operators. Now, by operators, that means add, subtract, multiply, and divide. Okay, so we had things like 4x plus 2y. That would be an expression. And we have a plus sign in there, which is our operator. We have letters and numbers. Okay, but the key thing is that there were never any equal signs in our expressions. Okay, so it says an expression is a collection of pronumerals, numbers, and operators without an equal sign. An equation is a mathematical symbol So it is a mathematical symbol that states that two things are equal. For example, there's a little e.g. there. If I make one up here, 2x plus 3, then I have an equal sign, x plus 5. So we have the 2x plus 3 on the left-hand side. Then I have an equal sign, which is saying that it is equal to the x plus 5 on the other side, the right-hand side. And so that comes to the next point. It says equations have a left-hand side. So you'll see for short there, LHS stands for left-hand side. And a right-hand side, which is RHS. And an equal sign in between. So here is another example. So 2x plus 3, that is our left-hand side. The 4y minus 2, that is the right-hand side. And in between the two of them, we have an equal sign. Dylan, can you please not do that? Equations are mathematical statements that can be true. So, for example, 2 plus 3 equals 5. Well, 2 plus 3 does equal 5. Or sometimes they can be false. Like 5 plus 7, that equals 12, not 21. So that next equation there is actually false. If a pronumeral, which is our letters, if a pronumeral is included in an equation, you need to know the value to substitute before deciding whether the equation is true or not. So for example, if we had this equation here, 3x equals 12, it would be true, so let's write the word true in there, it would be true if 4 was substituted for the x. Because 3 times 4 does make 12, doesn't it? But it would be false if 10 was substituted. Because 3 times 10, the 3x, makes 30, not 12. So that would be a false one. So it depends on what the number that you substitute in as to whether it's a true equation or not. The value that makes an equation true, which are the ones that we're going to focus on, that's what this whole topic about, is finding the true solutions, or true values, which are called the solutions. I was giving away the answer too early there. The value that makes an equation true are called solutions. For example, the solution of 3x equals 12 is x equals 4, because 3 times 4 correctly gives the answer of 12. Okay, question 1. We have some examples. Which of the following are equations? So remember, equation has a left-hand side, it has a right-hand side, and it has an equal sign in the middle. So the first one, we have a 3x plus 5 equals 8. Yep, that's an equation. It has an equals and it has things on either side. We're not actually worried about whether it's a true one or not. That's actually the next one. We're just identifying which ones are equations and which ones aren't. Part B, 2 plus 12. There's no equal sign there. That is not an equation. 4 equals 12 minus x. Yes, that is an equation. It has an equal sign and it has things on either side of it. And 3 plus u, that is not an equation. There's no equal sign in it. All right, question 2. State whether each equation is true or false. So T for true, F for false. Part A, 7 plus 5 equals 12. So 7 plus 5, just working out the left-hand side, 7 plus 5 equals 12 on the left-hand side. And I did have 12 on the right-hand side as well, so that is actually true. Let's try part B. The left-hand side, 5 plus 3 makes 8. And the right-hand side, 2 times 4 makes 8. Both sides are equal, so that is also true. Part C. Working out the left-hand side, remember you need to do brackets first, assuming that we're not using calculators for this. So 2 take away 1 is 1, and then I would do 12 times 1 equals 12. That's the left-hand side. On the right-hand side, 14 plus 5 makes 19. Does 12 equal 19? No, so we have our first false. That's a false equation. Part D. It says I have 3 plus 9x is equal to 60 plus 6 if x is equal to 7. So I have to substitute the 7 in to see whether this is true or not. So I'm going to have to do a little bit of working out over here. So 3 plus 9x, I'm replacing the x with the 7 because that's what I was told. Is that going to be equal to the right-hand side, which was 60 plus 6? What is 60 plus 6? It is 66. That one we can work out. Let's further simplify the left-hand side, doing times first for order of operations. 9 times 7 is 63. So you could do 3 plus 63 equals 66. And then you'd add the 3 on, which does give you 66. 66 equals 66, so that is a true equation. And E. Again, it's a substitution question. I want to sub that B is equal to 4 into that equation. Yeah?
Why did you do 3 plus 63?
You've got to do multiplication before you do addition, order of operations. So here, you enter that? Yeah. All right, so let's try it again. This one will be very similar. So 10 plus B, I'm replacing the B with a 4. So it'll be 10 plus 4 equals. Now I also need to put it into the right-hand side as well. 3B will be 3 times 4 plus the 1. So there's my 3B plus 1. I need to work out each side. On the left-hand side, 10 plus 4 makes 14. On the right-hand side, 3 times 4 is 12, plus 1 makes 13. So they are obviously not equal, so that is false. All right, let's go to the next page. In question 3, we are asked to write an equation for the following scenario. You are not being asked to write down what the solution is. Okay, we're practicing trying to make an equation. So I want to write an equation for the sum of x and 5, which is 22. So we learnt in our last topic, sum means to add, difference means subtract, product means to multiply. A lot of those kind of words will be in here again. So if I want the sum of x and 5, that means x plus 5. When it says is, that's my equal sign. It's saying what it is equal to. So that is 22. That's the equation. As I said, we're not solving it. We're just practicing taking the words and putting it into an equation. Part B. The sum of cards in a deck is X. Okay, so if I was to count up all the cards in the deck, it's X. In 7 decks, there is 91. So even though there is that word sum there, I am not summing the 7 with the X. If I have 1 deck of cards, I would have X cards. So if I have 7 packs of cards, I'm going to have 7 times X or 7X. We'll try to trick you with the wording a little bit sometimes. And then it says in those 7 decks there are, which means there's my equal sign, there is 91 cards. There's my equation. Don't need to solve it. Part C. Priya's age is currently J. In 5 years, her age will be 17. So if she's currently J, in 5 years' time, you're going to add 5 to that age. Right? So she's going to be J plus 5 in 5 years' time, which means that her age then is going to be equal to 17. Yeah, don't have to answer it, just have to write an equation. And one last one. Corey earns W dollars per year. He spends 1/12 on sport and 2/13 on food. The total amount that Corey spends on sport and food is equal to $15,000. I have to make an equation out of this. So, if he spends 1/12 on sport, he spends 1/12 of or times by the W, because we just know W is the amount of money that he earns, right? Plus, he's going to spend more money than that. He is going to spend 2 out of 13 on food, so I'm going to times that by the W as well, because each of those fractions are of the amount that he earned. So of means times. In total, so each one of those, this is how much he spends on sport. The second one is how much he spends on food. In total, we're told that that equals $15,000. Now that is an equation. However, it's probably not the most simplified way to write the equation, because we learnt in algebra that we prefer not to have multiplication signs in there if we can avoid it. So what we can do is we can put the fraction right next to the letter. If there is a 1 on the top, we could write 1W, but do we ever write a 1 when it's in front of a... That's right. We're just going to put a W over 12 for the first one, plus 2W over 13 for the amount spent on food, and that is equal to $15,000. Okay, so that is it. And you can see here, here's your instructions. In the workbook, we're doing exercise 1, which is page 2.